Okay, so we are going to do work that is specific for isosceles and equilateral triangles. You might want to pause your video so that you can get these diagrams copied down. So the first thing I'm going to do is, in example 1, is I'm going to look at what I have. What is my figure and my diagram telling me? So I'm going to be looking at my tick marks. So if you notice in example 1, I have the arcs in the angles. Down here, I have just a different kind of notation of the angles. And then down here, we don't have angle marks or ticks anywhere. So we'll talk about that when we get to example 3. So going back up to example 1, I have to look at my diagram. I know that these angles are congruent. So if the angles are congruent in a triangle, then I know that the sides opposite are also congruent. So that makes this figure an isosceles triangle. So if these sides are congruent, then I can set those two sides equal to each other. I'm going to add 8 to both sides. 9x equals 36, so x equals 4. So if x equals 4 and I plug this value in, I better have that this value actually does equal 28. Why do you think that this measure is here? And if you guess that it's just to screw you up, that is correct. So you're going to be given information that is not going to be needed in the diagram just to confuse you a little bit more. Example 2, again, I'm going to be looking at my tick marks. All of my angles are congruent, so I know this is equiangular. So just like what we did in isosceles, all the sides then are also congruent. So if this is equiangular, it's also an equilateral. Now we have 3 sides. We know that anything that I set up equal to each other, they better equal. So whether I set 7x minus 17 equal to 2x plus 3, or if I set these two equal to each other, or if I set these two equal to each other, they better end up working anyway. I'm going to choose these just because the numbers are smaller. So 4x minus 5 equals 2x plus 3. Subtract 2x on both sides. Add 5 to both sides. And I get x to equal 4. So I'm going to check my work by plugging 4 in. So if I put a 4 in here, that gives me 4 times 4 is 16, minus 5 gives me an 11. If I put a 4 in here, 2 times 4 gives me 8, plus 3, that gives me 11. If I put a 4 in here, 7 times 4 is 28. 28 minus 17, that gives me 11. Probably one of the most common errors here is people want to do 7x minus 17 plus the 4x minus 5 plus the 2x plus 3 equals 180. They rented a room. Think about what you're doing. These are sides. This has to do with angles. So this is a major no-no. Let's look at example 3. Again, no tick mark, so I got to look at the diagram. These sides are congruent, which means that the angles opposite are congruent. So if they're congruent, then I can set them equal to each other. So 7x plus 5 plus the x plus 47. Actually, this should be an equal sign. They should equal each other. Subtracting x on both sides, I get 6x plus 5 equals 47. Subtracting 5 on both sides, 6x equals 42. And then solving, you get x to equal 7. So what happens if I asked you to find the measure of angle H? Okay. So if I'm looking for the measure of angle H, I'm going to take the 7 and plug the 7 back in. 7 times 7 is 49. plus the 5 gives me a 54. So angle G is 54 degrees. This better be 54 degrees. So I have two angles that equal 54, and I know that all three have to add up to 180. So 180 minus these together give me 108, which gives me measure of angle H to be 72 degrees. So you're going to have to really look at your diagrams, put the information in your diagrams, and use the information that you have in order to set up the equations and solve the problems.